So we're going to start today with section 6.1. It's titled The Set of Rational Numbers. There's a fair bit, I believe, at the beginning of this section where it just feels like you're just definitions and things. So bear with me. I promise it's not always going to be like that. That happens a lot at the beginning of the chapters where we're just trying to set the stage so that we're all using the same vocabulary. So to start with, some terms that you're familiar with, but maybe haven't thought about in a while. Rational numbers, specifically. Rational numbers are the bottom of this, but sort of building up to that, we have fractions. Fractions are any number of the form a over b, where b is not 0. The numerator is the value on the top of the fraction, so in this case a. And then the denominator is the value on the bottom of a fraction. In that case, for the one here, it would be the letter b. So you've seen fractions at least since about 4th grade. They're actually introduced earlier than that now. Not in all of the capacity that we're going to work with them, of course, but the idea of parts of wholes, where you have, half of a cookie and stuff like that are introduced in about 1st to 2nd grade. My 1st grader, she's halfway through 1st grade, hasn't encountered them yet. I'm not sure if she will, but it wouldn't surprise me by the end of the year. Things have moved quite a bit earlier than you might have expected. Rational numbers are a very special type of fraction. They're a type of fraction where you can change, or they already are, the numerator and the denominator that are integers. So that means positive and negative whole numbers. Now, if you took anything in geometry, which you probably did, you encountered, for example, the number pi, right? Pi is not an integer. It's what we call an irrational number. So while pi over 2 is a fraction, pi over 2 is not rational. So just because I can put things with a fraction bar, between a top and the bottom doesn't make it a rational number. I have to be able to write the numbers on the top and the bottom in an integer form. Now, let's say, for instance, that you did have, like 0.5 over 2. Well, 0.5 is not a rational, or is not an integer. But I could change 0.5 over 2 into something that has equal value to an integer. For example, if I had that 0.5 over 2 and I multiplied the top and the bottom by 2, I would actually get a whole number 1 on top and the number 1/4 on bottom. So if I can manipulate it and I can create it to have an integer top and bottom, then it's still a rational number, even though this original form of it didn't quite fit the description. Does that make sense? But there are numbers that don't fit here. Pi over 2 would be one of them. That would not be a rational number. There's several uses of rational numbers. We're going to talk about 4 of them specifically. The first one is called, or is what we're going to refer to as a solution. For example, if you were solving the equation 2x equals 1, what does x equal? 1/2. And if I don't have rational numbers, I don't have a 1/2, right? When my daughter, who's 7, is counting, she does not go 1, 2, 3, 4, 5. I mean, she does go 1, 2, 3, 4, 5. She does not go 1, 1.5, 2, 2.5, 3, 3.5. But we all know that there's numbers in between those, right? But her universe doesn't include those in-between type numbers yet. But in order to solve equations like this, we need them. So that's one use of rational numbers. Another use of rational numbers is as a partition. For example, if you would say something like 1/4 of my paycheck goes to gas. It's a portion of a whole. This is a part of a whole idea. The whole is the paycheck, and 1/4 of it, 1/4 of it is the cost of your gas. Ratio, as in the word rational, right? The shortened form ratio comes from rational. Ratio is another one, and you have heard ratios a lot because the profession you're about to go into likes to use the word ratio. So, for example, the teacher-student ratio is 1 to 8. So we can write it 1 to 8 with words. We could also write it with a colon in between, 1:8. Or you could actually write it as a fraction, 1/8. Okay, so if you're sort of describing something, that's probably the least helpful. Colons or the word 2 between them is probably the most useful. But you see ratios used all the time, right? So like when I open a little bag of Skittles, I want the ratio of red and purple to the rest of them to be really high, because I want the red and the purple ones. I don't want the rest of them personally. When you go looking for colleges, you typically will see on college websites the ratio of faculty to students. And what they're trying to get you the sense of is how big your classes are going to be, right? It's a selling feature if you have smaller classes, hence more faculty to fewer students, kind of that ratio. Probability is the last one that we're going to look at, and I'll do another example to show a probability being used. When you roll a die, you have a 1 out of 6 probability of rolling a 5, for example. Right? Standard 6-sided die, 6 sides, one of them has a number 5 on it. So probability is something that we will talk a lot more in detail later in this semester, but it's a use of rational numbers as well. All right, so let's look at some pictures. You have these pictures, although you don't have the colors, of course, on your paper. And I'm going to give you just a second to write the answers down, and then we're going to all confirm together what we should have written for the fraction represented by the picture. So take just like 30 seconds to a minute, something like that, and write down the fraction that you believe that the shaded portion represents of the entire picture for A through D. Okay. If you're not quite done, it's okay. I'd like for you to take a step back, and I'm going to ask you a slightly different question than the answers you just wrote down. Imagine that you're a young child who's first learning about fractions. What might you say the fraction of the first picture is that it represents? What? 1/4. Okay? Now, some of you might not have seen fractions for a while, and you just might have written 1/4 for yourself, and that's okay if you did. But for those of you who recognize that that might be what a student would think that this answer is, why? Why might somebody look at this and think the answer is 1/4? Yes, ma'am?
Because there are 4 sections and only one's shaded.
Right. Does everybody see that? It's a natural thing to look at that and maybe think. There's 4 sections, one of them's shaded in, so I have 1 section out of 4. What's the problem with that? The sections are not the same size, right? So if you split the cake like this and somebody says you get that piece and you got 1/4 of a piece, you would probably argue with them and say, I did not get 1/4 of the cake, right? You probably would, because you recognize that something about that's not the right size. So one of the things that you can do to make it easier to think about, and maybe some of you did, is by actually making the boxes the same size, right? Cut them into equal pieces, if you will. And if you do, what do you get as the fraction that this is really representing? Yeah, it's really 1/6. So again, what might someone say is the value of the fraction for part B? They might say 1/5. Now, again, the pieces aren't the same size, so the answer is not 1/5. But it's not quite as clean to just drop a couple of little pieces in and even them all up, right? You almost have to do something like eliminating the pieces that are there. So for example, I need this line to go away, and I need this line to go away. And then it becomes a picture far more like the one I had before, and I can drop in an extra piece to make them 4 equal pieces. Now, it's not the only way to do it. We also could drop these little pieces in like this and split everything up like that. And that would be okay too. All right, so the other picture that I drew was very clearly 1/4. If you did this picture, you might look at it and say that there's 3 out of 12 shaded in. And we'll talk more about why this is the case, but these are equal to one another. So they're both equal ways of writing the same fraction, depending on your perspective. C is a little different. At first glance, you might have been inclined to say how many out of how many are shaded in. You might have said 2 out of 8. And the reason that you might have said 2 out of 8, I know some of you counted because I watched you doing like this. This is great. You should definitely count. Awesome. Well done. Is because this is a familiar object to us. It probably looks like the pizzas that you get at your house, right? Get delivered or you pick up or whatever. And pizzas are often divided into 8 pieces. Not always, but often. So if you're looking at first glance and you're not being careful to count, you might have said 2 out of 8. If you're being more careful, you probably said 2 out of 7. Now, A, B, and C are all examples of diagrams that represent part of a whole. There's a whole object and part of it is shaded in. All right? D doesn't look like that at all. There's not a whole. This is more like my M&Ms or my Skittles example that I did Skittles just a minute ago where I talked about my Skittles, right? There's actually a bunch of individual objects here. Some of them on my screen are blue and some of them are sort of hollow and not filled in. So what did you get as a representation here? What was your fraction? 7/12 is correct, yeah. And it's not any different in the terms of counting them, but there is a very different representation here for a child. This is not the same picture. This 7 out of 12 does not look like a 7 out of 12 pizza that's divided into 12 pieces and there's 7 of them missing or 7 of them present. The image is quite different. Oh, we're not quite ready. So there are different representations. Some of them are part of a whole, like the first 2 or first 3, and some of them are called a set representation is the last one actually, where you've got a bunch of objects and you're talking about more like a ratio kind of instead of it being a part to whole kind of a value. All right, so we're going to stop there for today. It's a great place for us to stop. We will start next time with the historical notes part. I would encourage you, if you haven't already, to make sure you know how to scan PDFs, because we're going to need to know how to do that pretty quick. Come see me if you need help. And that you go ahead and print out at least all of Chapter 6 notes. If you want to print out everything so that it's all ready and you don't have to remember to print out everything in the future, you're definitely welcome to do that as well. Have a great day, guys.